So today we're going to talk about savings plans and loan repayment. And I think this will be a little bit more real life applicable than what you've seen in the past. So let's start off by just thinking about savings plans for a moment. In other math courses, we usually say something like, okay, you have $1 million or $1,000 or something, you put it into an account earning some awesome interest rate, and then you leave it there for some amount of time, and then you get some money back. More typically, what we do with savings plans is you save some amount per month. You save, let's just say X amount per month in some sort of plan. So there's a couple different types of plans that come up in the real world. You'll hear the words 401k, which is usually through your employment. 403b is another one similar to 401k. There's Roth IRAs, which are personal savings accounts for retirement. And then there's also 529 savings plans. These are for college. So these first three are all for retirement. And this one here is a college plan. So the first two, the 401k and the 403b, I'm not going to really talk about those. These work a little bit different. These are usually through your employer and are very good to do. I strongly recommend taking a look at those. But I want to talk more about the other two today, the Roth IRA and the 529. These are more personal ones that you can start up. So these are personal accounts, meaning you're in charge of them. You don't have to worry about your employer. And the money goes in after tax, whereas the other plans are before tax. So these operate more like savings accounts than retirement accounts. Now, I'm not going to go through all the legalese of all of these. I'm just going to talk more about what they do. You can look into them on your own at some point. I have a Roth IRA and a 529, and I do that through my insurance company. But there's other ways to do it as well, and it's pretty easy to get started on that. So I'll let you explore that more later on if you want, but I'll give you just some of the details on what you can save and what you can, how you can plan for retirement here. So first of all, I want to give you the savings plan formula, which is kind of a beast. I usually don't have this memorized. I do have to look it up. So we're going to say our amount equals PMT, which stands for monthly payment, times, now here's kind of a mess, we're going to have a fraction 1 plus APR, which we'll define in a moment here, to the power of NT minus 1. And then all of that gets divided by APR over N. I like to include parentheses on the numerator and denominator. Even though they're not technically required, I like to do that just to remind myself when I'm using the calculator to do this. So A is the amount after some time. PMT is your monthly payment, or really it could be anything, quarterly payment, whatever you want it to be. Your APR is what's called the annual percentage rate. So this is what we usually call the growth rate or the interest rate, but the formal term is APR. And then N is always just going to be 12 for us, but really this is sort of the number of times per year you put money into your account. So we're just always going to assume a monthly payment, and that's usually how it works in the real world. But if you ever see some sort of account that does things quarterly, for example, it might be 4, or you might have some other options as well. But we're just always going to say N is 12. So I'm actually going to go back now and replace all the N's with 12s. And we'll just assume from now on that we're just going to use 12 for that. Okay, so let's try a couple of problems out here, and the numbers I'm using are actually pretty realistic. So let's just say, for example, the first one is me. We'll say Mr. Edwards deposits $100 per month into his Roth IRA. And this is pretty realistic. When I was younger, it was $50 per month, and as I've gotten older, I've put more in per month as I have more money to spare. And let's just say the Roth IRA historically has earned, let's go with about 8.7% APR, which is a lot. You won't see this in a savings account, but with Roth IRAs, you actually do historically see a pretty high amount. It's usually 8 to 12. And you can look at that historical average over the last 70 or 80 years in any account you have, and they'll tell you what it is. Okay, so back to the example, $100 into the Roth IRA, 8.7%. Let's say if I started at 23, how much will he have when he retires at 65? Okay, so quite a few words here and numbers, but all that this comes down to is plugging into a formula. So what I'm going to do is I'm going to write the amount he has equals that $100 times 1 plus 0.087 divided by 12 to the power of 12 times, I don't know how many years it is, so let's do 65 minus 23. We have to do minus 1 in the numerator as well, and then all of this gets divided by 0.87 divided by 12. So we plug this into a calculator and we see what we get. So let's go ahead and open up a calculator. We're going to go 100 times, now I'm going to have to put a lot of parentheses in here, so I'm going to use some extra ones just in case, divided by 12, and then we go to the power of 12 times more parentheses 65 minus 23. You can also do this piece by piece. You don't have to do it all in one go if you don't want to try to work out all the parentheses. And then let's go ahead and divide by 0.087 divided by 12. Okay, so $512,041.46. So Mr. Edwards will have about $512,000, well, $512,041.46. 41.46. Yep. So Mr. Edwards will have $500,000. Excuse me, which is pretty awesome. Excuse me. Oof. So, and these are realistic numbers, right? I could save $100 per month. That's not unreasonable. I could get an 8.7% APR. That's also not unreasonable. So that's a pretty decent setup, actually. And obviously, this is not exactly accurate because I have changed the amount of money I'm investing. Okay. So let's change up the problem just a little bit now. Let's talk about a 529 plan. So let's say that Mr. Edwards wants to save for his son's college, and he wants $50,000 for his son Luke. For college in 18 years. We'll just say Luke goes to college when he's 18. So Mr. Edwards uses what's called a 529 plan. And the question I'm going to ask is, if his 529 plan earns 2.3% APR, which again is not totally unreasonable. 2.3 is a lot more than a savings account, but it's actually pretty low for a 529 plan. The question I'm going to ask is, how much should he invest per month? All right, so let's set this up. Now in this example, you're given A, 50,000. You don't know the monthly payment, but you do know that I have 1 plus, here's my APR. I know that I need to wait 18 years, and then I'm going to divide that by 0.023 over 12. Now notice, it's a mess, but it's just the monthly payment is being multiplied by some big amount. And so really all I have to do is I'm going to divide both sides by whatever this is. So it's going to end up being $50,000 divided by all of this stuff will equal my monthly payment. So let's go ahead and use our calculator again. And let's go with, let's see, use some extra parentheses again. 1 plus 0.023 divided by 12 to the power of, now I do have to use parentheses, undoes most, extra parentheses, and then minus 1. We will divide by 0.023 over 12, and I get about 267.2649. So then what I'm going to do is immediately just say 50,000, and I'm going to divide by this little ants button down here is right underneath the 3. I'm going to use that so I don't have to worry about any rounding errors. And so I end up with 187.08. So this was about 267, I don't remember what it was. And so then my monthly payment ends up as about 187.08. So we'd say, well, Mr. Edwards has to save about $187.08. Again, not totally unreasonable. That is quite a bit. So that I might not save all of that, maybe go down a little bit from there, but not a completely unreasonable amount to have $50,000 in 18 years. And that would probably pay for most in-state schools and in-state tuition. Okay, let's do one last one. Now we've been talking about exponential and log equations, so I want to do one that involves logarithms. So let's go back to my first example. Same setup as the first example. So I'm still investing in my Roth IRA, same APR, except for I'm going to change it up a little bit. Mr. Edwards wants to be a millionaire. So he wants $1 million when he retires. So the question is, how long should he wait before taking out his money? So rather than, 65 hits and I can immediately retire, take all my money out, or probably not all of it, but take out a certain amount per year or month, let's say I want to have $1 million instead. So how much longer should I wait before starting to take out my money? So let's go ahead and set this up. Once again, you're given the amount is $1 million. You know the monthly payment was 100. And then I'm going to multiply by this mess again, 0.087 over 12. But now I don't know what t is. So notice that's in the exponent. So you can already start thinking, well, we'll have to use some logarithms. Okay, so let's start off by thinking about what we need to isolate. So I need to isolate that t, which means I really need to isolate the exponential part of this, which is right here. So that means I'm going to have to add the 1 eventually. I'm going to have to multiply by the denominator, and I'm going to have to divide by that 100 out front. So let's just start going ahead and solving this. Let's divide by 100 from both sides. So I end up with the same number with a few zeros lopped off. So it looks like that's going to give me 10,000. And then I'm going to have 1 plus 0.087 divided by 12 to the power of 12t minus 1. So then what I'm going to do is I'm going to take that denominator and move it to the other side, and I'm also going to add 1. So I'm going to have 10,000 times 0.087 divided by 12, and then plus 1. And now we're in a position where we can use logarithms to solve. So we're going to go ahead and rewrite this as log base 1 plus 0.087 of this stuff. I would probably be doing this on a calculator as well if I were you, just kind of making sure that you're doing intermediate steps rather than doing this all at once. And then as the final step, we'll divide by 12. So let's go ahead and see what we get here. So I have 1 plus 0.087 divided by 12. And then I need log with that base. So let's go ahead and click on log. Except remember, we can't do log base on this version of the calculator, so I'm going to go with log of, what was it, 10,000 times 0.087 divided by 12 plus 1, and then we'll divide this by log of the base. Which I can just click answer because that's what I got before. So I get 594, and now I need that divided by 12. So I get 49.57. So we end up with t is approximately 49.6 years. So Mr. Edwards should wait 49.6 years. Remember, he started when he was 23. So that means he will be 72.6 years old. So we'll say he should wait until he is 73 years old. Okay. All right, so the math side of things in today's video was sort of a further application from section 3.4 and just kind of at the pinnacle of chapter 3. We got into some application problems. But really, I also want you to take away from this that you can start saving, and you can actually get quite a bit of money by the time you retire by not investing a whole lot now. I started saving when I was 23, and I wish I would have started when I was 18. I would have quite a bit more money in the account just by those extra 5 years. You get basically an extra doubling period every 6 years you have this account. And so if you think about doubling that 512,000, I would actually have $1 million instead of 500,000 when I retire. So it's definitely worth looking into this. And then when you do have kids, potentially, if you want kids, you can look into a 529 savings plan and think about saving for college, which is also a great investment plan, in my opinion. But don't take my advice. Always talk to a financial advisor instead of your math teacher. So that concludes our savings plan video.